Hello, everyone. Today we're going to do packet tracer of CCNA1 version 7.9.3.4. Packet tracer IPv6 neighbor discovery. Here's the addressing table, device, RTA. RTA is a router. And three PCs, PCA1, PCA2, PCB1. So from this topology, we can tell these two computers, PCA1 and PCA2, are in the same subnet network 1. And PCB1 is in subnet network 2. And this is a IPv6 address. We know that in IPv4, IPv4 has 32 bits. We use binary to create the IPv4 address for the network address and host address. And in IPv6 has totally 128 bits. And we use a hex decimal value to create the IPv6 address for the network address and the host address. And these 128 bits are evenly split into two parts. The first part, 64 bits, represent the network. The other part, 64 bits, represent the host. And also, these 128 bits are evenly split into 8 hexstates. And these hexstates are divided by the colon sign. And each hexstate has 4 digits. These digits are hexadecimal digits, and each digit has 4 bits in binary. So each hexstate has 16 bits. Look at first 3 hexstates represent the network. It is called 48 bits global routing prefix. These 3 hexstates represent the network, which assigned by the ISP, Internet Service Provider. And the 4th hexstate represent the subnet. It is called a subnet ID. And the rest 64 bits or the rest 4 hexstates represent the host portion IPv6 address. Like here, the double column A is the host portion IPv6 address for PCA1. And double column B is host portion IPv6 address for PCA2. And double column A is for PCB1. These letters are hexadecimal value. Let's keep going. Objectives part 1, IPv6 neighbor discovery local network. Part 2, IPv6 neighbor discovery remote network. Background: in order for a device to communicate with another device, a MAC address of the destination must be known. With IPv6, a process called neighbor discovery using NDP or ND protocol is responsible for determining the destination MAC address. Here, the NDP is similar to the ARP in IPv4. ARP is ARP, Address Resolution Protocol. The both NDP and ARP have the same function, that is to find the destination MAC address. You will gather PDU information in simulation mode to better understand the process. There's no packet tracer scoring. Okay. Instructions part 1, IPv6 neighbor discovery local network. Local network is the communication between 2 devices that are in the same network, like here, PCA1 and PCA2. So their communication is a local network communication because they belong to the same subnet network 1. Step 1, check the router for any neighbors that it discovered. RTA router, okay, go to RTA router. CLI is a command line interface. And right now we're in the user executive mode. We use command enable to enter the privileged executive mode. And from here, we can use show command to show IPv6 neighbors. Okay, so in my case, there's no any information of neighbors displayed here, or no any neighbor table displayed here. In your case, if there's any neighbor information displayed, you gotta use second command, cl clear IPv6 neighbors to delete the neighbor information, or to delete the neighbor table. The neighbor table is stored on the router, so now we delete it. So now we go to PCA1. Okay, PCA1, command prompt. Okay, let's go. So here, so step 2, switch to simulation mode to capture events. So we're currently on the real-time mode. Switch to the simulation mode. All right, simulation panel displayed here, and D show all noun to display noun. So right now there are 2 events displayed here. We show noun, so show noun. That's what we need to do. And if we click again, all the events will displayed here, but we need to display noun. From the command prompt, PCA1 ping in PCA2. So now we need to ping from PCA1 to ping PCA2. So let's go to ping space -n, n is number, space one is one time, space, then followed by the PCA2's IPv6 address, which is 2001, column DB8, column ACAD, column 1, double column B. Okay, enter. Okay, so we ping and a capture forward button here. Both are capture forward button, both works. You can click either one. So here the captured to 0 second. So capture to change to 150 second. So here, look at here the sent one, received one. Usually Windows will automatically ping 4 times. Should send 4, received 4, but here send 1, received 1. That's because we limit the ping to only one time, only ping one time, the number one time. So that's why here sent 1, received 1. And go to edit filters here. IPv6 tab, select ICMPv6 and NDP. ICMPv6 is for ping. NDP is neighbor discovery to find the destination MAC address. All right, so let me adjust this size for easy to read. So here are the questions. Why are ND PDU present? So there are 2 PDU present. One is ICMP, the lighter green. It's ICMPv6. This one, the dark one, is NDP. Why NDP displayed here? Remember, before we ping, we delete the neighbor table on the router, and the destination MAC address is on that neighbor table, but we delete it. So now, without the destination MAC address, this ping cannot be completed. In other words, without the destination MAC address, this ICMPv6, this packet, doesn't know where to go physically. Even though we know the destination IP, but IP address is a logical address. Any computer can be configured the same IP address. Like here, if we change this computer to another computer and put it to here, and another computer can be configured as the same IP address. But MAC address is different. MAC address is physical address. It is burned into the hardware. So each computer has a unique MAC address. And also, the communication between these two computers is a NIC-to-NIC communication. So in order to complete this ping, the source device has to know the both destination IP and destination MAC address. But now, without the destination MAC, the source device has to use NDP to find the destination MAC. That is a function of NDP. All right, so here is the answer. Okay. Because PCA1 doesn't know PCA2's MAC address, which is the destination MAC address. Without the destination MAC address, the ping from the source device cannot be completed. PCA1 must use NDP process to find find the PCA2's MAC address. Okay, next, click the square in the type column here, type column, the first event, which should be IPv6, yes, on the PCA1, the first. Because the message start with this event, there's only outbound PDU, yes. Under OSI model, the question, what is the message type listed as IPv6? OSI model. This OSI stand for Open System Interconnection. The ICMP-v6 echo message type 128, that is the answer. All right. Yeah, here, 128. Here the echo is echo request. Here the echo request. Here the number is 128. 128 is for echo request. Later on you will see echo, but the echo with the number is 129. But 129 is echo reply. So I tell you here early so you will not confuse later. Remember, 128 is echo request. 129 is echo reply. And here, notice there's no layer 2 addressing. Click next layer button to get an explanation. Okay, next layer. All right, so this layer 2 information are missing. So next hop IP address is unicast. Okay, look at here. The source IP and destination IP both are global unicast IP address. When we study IPv6 address, there are different type of IPv6 address. When you see the IPv6 address starting with 2001, this type of IPv6 address is global unicast address. And the global unicast address is a routable address. So here, both source IP and destination IP are global unicast address. So here's the next hop IP address is a unicast address, yes. And the process looks it up in the neighbor table, but we deleted the neighbor table already. The next hop IP address is not in the neighbor table, that's correct. The NDP process sends neighbor solicitation for that IP address and buffer this packet. Neighbor solicitation is request. So NDP process will send the neighbor request for that IP. Okay, so we finished H. So click the square next to the next event in the simulation panel. So PCA1 NDP, PCA1 NDP is here, the second one. So we're going to use NDP to find the destination MAC address. Square the questions. What changed in the layer 3 addressing. Changed. Look at layer 3 addressing is IP address. The source IP is still the source device IP, the global unicast address, but destination IP changed to this is a multicast IPv6 address. It is another type of IPv6 address. When you see the IP address starting with FF02, this type of IPv6 address is called multicast IPv6 address. So here the neighbor message is 135. Here neighbor is neighbor request. Here, neighbor solicitation. Solicitation is a request. Later on, you will see neighbor, but with the number 136. 136 is neighbor reply. Here, 135 is neighbor request. So let's copy this. Okay, destination IPv6 address changed to this multicast FF02 from a unicast address. What a layer 2 address? Layer 2 is MAC address here. This is source MAC is still the source device MAC. Source device is PCA1, E8ED. So here, E8ED. The MAC address all the way to the right, the first one. So that is source MAC. Destination MAC is a multicast MAC, starting with 3333. This is a multicast MAC address, destination MAC address. So we can okay. Source MAC is PCA1's MAC. Destination MAC is a multicast MAC address. One host does not know the MAC address of the destination. A special multicast MAC address is used by neighbor discovery as layer 2 destination address here. This is the special multicast MAC address. Next. So let's go NDP switch A, the third one, switch A NDP. Is there any difference between the in layers and out layers for layer 2? In layers, layer 2, out layers, layer 2. In layers for information coming in, out layers for information sending out. So their source MAC, destination MAC, source MAC, destination MAC, they are the same. So the answer is no. Answer is no. That's because the switch doesn't do anything to the layer 2 information, doesn't change layer 2 information. Switch only pass the packet or only forward to the packet. Okay, next one. Select the first NDP event at PCA2. PCA2 is a destination device. Click outbound PDO. Okay, here, PCA2 NDP. Outbound PDO is here. What address are displayed? Okay, they needed this address, so we just copy this information, destination address, destination MAC address, because this is under the Ethernet 2. Ethernet 2 is layer 2. So we copy this destination MAC and source MAC. And this is source IP, destination IP. Still copy paste to here. This is destination IP. Yeah. All right. So here's the destination MAC is PCA1. Source is PCA2. Source PCA2. Destination is PCA1. Because they switched. Okay, go to OSI model. We can see PCA2 is a destination device. Okay, the destination device receive the neighbor request is with the number 135. And here we'll reply, this neighbor reply 136 back to the PCA1. So this neighbor reply will travel in opposite direction back to the source device. So before the source IP, double column A, become the destination IP. Before the multicast destination IP becomes the unicast source IP, which is the PCA2, double column B, PCA2's IP address. And before the source MAC becomes a destination MAC, before the multicast MAC becomes the unicast source MAC. This source MAC corresponds to this source IP. So this MAC address is PCA2's MAC address. This neighbor reply will bring this PCA2's MAC address back to the PCA1. At PCA1, use it to complete ping. So that is the process of NDP. Here the neighbor reply is 136. Yeah, neighbor request is 135. Okay. Next, select first NDP at router RTA. Why are there no outbound? Let's go here, NDP RTA. All right, so no out layer. Why no out layer? The question is why no out layer? Here, RTA router received this neighbor request 135, neighbor request from PCA1 through this default gateway interface, right? But in this neighbor request packet, the destination IP is multicast IPv6 address. But this default gateway interface IP address should be unicast IP address. Let's go here. So look at the IPv6 address, first one in the middle, 2001. This, the first IPv6 address is the default gateway IP address. So this is a unicast, global unicast address. Doesn't match this multicast address. So that's why the router will drop this neighbor request packet, or the NDP process will drop this neighbor request. That's why there's no out layers information coming out from router. Okay, here is the answer. Click the next layer to the end. Okay, so step 4 through 7. So here packet is a neighbor NDP, yeah, neighbor request. Device process, the router will process it, and this neighbor is neighbor solicitation request. The neighbor solicitation target IP address. Target IP address is the destination IP address. The neighbor address is the multicast address. The receiving doesn't match the receiving port's IP. Receiving port is this default gateway interface. So they don't match. Default gateway is unicast, but this destination is multicast, so they don't match. So that's why NDP process drop the packet. That's the reason. Okay, so click the next IPv6 at PCA1, PCA1's. Okay, so now this time PCA1 has all the information about destination device, right? Sure. The question, does PCA1 now have all the necessary information to communicate with PCA2? Yes, have both destination IP, unicast, destination MAC, unicast. Yes, the answer is yes. Yeah, because PCA1 now has both IPv6 and the MAC address of destination device PCA2. Next is the last IPv6 events at PCA1. Last one should be this one. Last ICMPV on PCA1. Okay, here is note. This is the last communication. Okay, what's the ICMPV6 echo message type? Echo message type is 129. 129 is echo reply. Go here. Here, look at here. Echo reply. Echo reply. Oh, here. Yeah, echo reply. All right, so next is P. Okay. Click reset simulation button in the simulation panel. Reset here. And from PCA1 pin, repeat the pin PCA2. Okay, let's go. PCA2 pin. I use up arrow pin again. All right, so this time only one PDU displayed here, which is ICMPv6. Button 5 times. Okay, here, forward, capture forward button. 1, 2, this echo. 3, echo. 4, echo reply. Echo reply. This pin is completed. It's successful. Yeah. The first pin is echo request and echo reply. The question were, why weren't there any NDP events? Because in the previous steps, we use NDP to find the destination MAC address already. So right now, PCA1 just use that destination MAC address to complete pin. So the NDP process is completed. We don't need that NDP. Because the function of NDP is to find the destination MAC address. In the previous steps, we used the NDP process find, find the PCA2 MAC address and brought it back to PCA1. NDP process is completed. We don't need NDP. So we finished part 1. Part 2, is a neighbor discovery remote network. Okay, so in part 2, this activity, you will perform steps that are similar to those in part 1, except in this case, the destination host is on another LAN. Observe how the neighbor discovery process differs from the process you observed in part 1. Pay close attention to some of the additional addressing steps that take place when the device communicates with the device that is on a different network. So he said it's a reset simulation. Okay. And I go back to the simulation, real time capture. Before we continue, and I have to talk about in the local network communication between the source and the destination is only one hop. From source to destination is one hop in the local network communication. But this part is a remote network. Remote network is the communication between two devices that are in two different networks. Like here, from PCA1 to PCB1, these two computers are in two different subnet network. One is in subnet network 1, one is in subnet 2. So the communication between PCA1 and PCB1 is remote network. So the communication from source to destination is not one hop. Not one hop. It's two hops. That's because the router involves. The function of the router is to interconnect the different networks. So after the router involved, the from source to destination become two hops. The first hop is from source to the router. The second hop is from the router to the destination. Two hops. So when the packets travel remotely, the IP address doesn't change, but the MAC address will change. The source MAC still source device MAC. But when the package arrive router, the destination MAC will change to the router default gateway MAC address. That's because MAC address only can travel within the same network. MAC address cannot travel to another network. So that's why the farthest place the MAC address can travel is the default gateway. So when the packet wants to travel to another network, the local LAN default gateway MAC address will become the destination MAC. After router receives these packets, the another default gateway MAC address will become the source MAC for the second hop. The destination MAC is a destination device MAC. All right, remember there are two hops. First hop is from source to router. Second hop is from router to the destination. The MAC address will be changed to the default gateway MAC address. Reset. Okay, capture for display and clear any entries in IPv6 neighbor device table as we done. So go to remote router. Okay, let me show again. Show IPv6. No neighbor. Let's clear neighbor. So now we don't have any neighbor information on the router. Switch to simulation mode. Okay, here, two events display here. Show all now. Okay, show now. And PCA1. From PCA1, ping PCB1. Ping PCB1. PCB1 is in another network. So from PCA1, ping PCB1. So I use up arrow. PCB1 is in subnet network 2, and the host portion address is A. All right, so ping one time. And capture forward button. So capture change to 150. So here, and we need to edit filter IPv6 and NDP. All right, so two PDU displayed here. And click X and IPv6 because message. Click the first one, the red one, IPv6. Yeah, we did the same thing in the first part because the message start with this event. Yes, only outbound PDO. Yes, correct. No. Yeah, the layer 2 information missing. When you see layer 2 information missing, that means the next step you need to do is to use NDP to find this layer 2 information, especially for the destination MAC address information. Yeah, here, click NDP at layer at PCA1 NDP. So NDP process start, and what's the address being used for the source IP in should be outbound PDU. Look at the source IP. Before, in the local network, the source IP is global unicast, starting with the 2001. But here is another type of IPv6 address, which is link local address. So source IP changed to link local address. When you see the IPv6 address starting with FE80, this type of IPv6 address is called a link local address. Link local address is not a routable, only can be used within the same subnet network. Okay, the link refers to subnet. So here, what's the source? The answer is here. So here, FE80, that is the link local address, is not routable. The link refers to subnet. So this link local only can be used within the same subnet network. Obviously, neighbor discovery will determine next to destination forward. Click the ICMP. Second, okay. Second IC IPv6 on PCA1. All right. So now has enough information to create echo request. Here's the echo request is 128. What MAC address is being used for the destination MAC? Destination MAC. As I said, destination MAC should be the default gateway MAC address. Okay, here, 6301. Look, the MAC address all the way to the right, the first one, 6301. That is default gateway MAC address. Okay. So here's the answer. Yeah, this 6301 default gateway interface G000 on the router. That's a default gateway MAC address. G000. So yeah, here I go here. Preference. Show here. Yeah, here. This is G000. This is G001 default gateway interface. All right, so click the next IC and IPv6 router. On the router, outbound PDU. Notice that outbound PDU from router, it's a destination layer 2 address. This means that again has to perform the destination. So here, the router, the layer 2 information missing. That means that means router has to use NDP process to find the destination MAC address. Okay. Yes, that's what it means. And skip down to first IC and IPv6 for the device. First IC and IPv6 on PCB1. PCB1. IC and IPv6 first. IC and IPv6 on PCB1 is this one. Okay. The question, what is missing the outbound? That means the layer 2 information, the source MAC and destination MAC. All right. So that means PCB1 needs to use NDP to find the destination MAC address. Here, destination MAC address should be the default gateway G001, this interface, default gateway MAC address. Okay, this is 129, it's echo reply from PCB1. The next few NDP events are associated with the remaining IPv6 address to MAC address. The previous is a link local address. Skip to the last set of ICMPv6. Last ICMPv6 is on PCA1. Information is null. So required information now is null because PCA1 knows the destination IP, destination MAC. Here, destination MAC is, oh, here, this is echo reply received. Source is this one. Source MAC is this default gateway MAC address. Destination is PCA1's. Okay. So next, click the reset simulation. Reset. Okay. And from PCA1, repeat ping PCB1. Okay. PCA1, ping PCB1. Let's ping again. PCB1. Okay. All right. So this time only one PDU displayed here, which is ICMPv6 for ping. Repeat ping, yes, capture 9 times. Okay, now it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, the ping is successful. Okay, so here the question, 9 times. So what were there any NDP? No, the answer is no. That's because the NDP process is completed. Yeah. Click the PCB1 event, the only PCB1 in the new list here, this one. All right. The question, what does destination MAC address correspond to? Destination MAC address here. As I said, destination MAC address should, here is a PCB1. Destination MAC address should be default gateway MAC address. So here, 6302. Okay. The second MAC address all the way to the right at the second one. Second one is for the subnet network 2, 6302. That's default gateway MAC address. So here is the answer. Okay. Destination MAC address is this one, which corresponds to the MAC address of local LAN default gateway interface G001 on the router because default gateway MAC address is the destination MAC address. Why is PCB1 using the router interface MAC address to make it ICMP PDU? That's because the reply will go back to PCA1, but PCA1 is in different network. So the destination MAC address should be the default gateway MAC address. Here's the answer. Okay. Okay, step 2, reset. Go back to real time. Okay. Step 2, examine the router. Return back to the real time. Okay. Click router. Okay, so now let's look at the neighbor table on it. So show, I use up arrow, show IPv6 neighbors. All right. So question, how many addresses are listed? So answer is 4. Is 1, 2, 3, 4. 4 addresses. What devices are these addresses associated? The 2 devices, PCA1 and PCB1. This first one, double column A, is PCA1's global unicast address. This one is PCA1's link local address. This is PCB1's global unicast address. This PCB1's link local address. One computer has 2 IPv6 address. One is a global unicast address. One is a link local address. Global unicast is routable. Link local is not routable. Because from this MAC address, we can tell they belong to the same computer. PCA1, E8ED, PCA1, E8ED. Link layer address is MAC address, right? This is E9E91, that's PCB1. 9E91 is PCB1. All right. So are there any entries for PCA2 listed? Answer is no. Why? That's because in the PCA2 doesn't involve in this remote communication. That's why no. Okay, so next, ping PCA2 from router. PCA2 from router. Let's ping from router to ping PCA2. That is ping 201 DB8 ACAD column 1 column B. Okay, enter. Success. Okay, let me make it simple. All right, so success. So let's ping again. They ask us to issue. Oh no, not ping again. Let's show neighbor table again. Show neighbor table again. So this time the question, are there entry for PCA2? Yes, is here. This is a global unicast address. This is a MAC address. Yes. All right. From here, there's very interesting. For the link local address, look at here, there's a MAC address. E8ED, here E8ED, 7E, 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 42 is 42, and 01, here's 01. Yeah, from here we can tell they use the EUI64 process to create this link local address. What is EUI64? That is, EUI stand for Extended Unique Identifier. They use EUI64 is turn this MAC address into the 64 bits link local host portion address. What that mean? Look at the MAC address use the hexadecimal value as well, but MAC address has only 48 bits, 3 hexadecimal. We insert FFFE here. Look at FFFE in the middle of the MAC address between 2 and 7, between 2 and 7. Insert FFFE to the middle of the MAC address here, FFFE. The middle of the MAC address is between F and 6, right? And then flip the 7th bit from 0 to 1. Because this digit is a hexadecimal digit. So the first 2 digits actually has 8 bits in binary. So the 7th bit is on the 2nd digit, the third bit. So the 2nd digit, 0, the flip the 7th 0 to 1. So the 2nd digit will become 0010 in binary. So 0010 convert to hexadecimal is 2. So here, that's why it's 2. So become the 0201. In short, it's 201. It's a 0260. It becomes a 260. This is a EUI64 process to create link local host portion address from MAC address. All right, we finish this. Reflection question. When does a device require the IPv6 neighbor discovery? I just gave you an answer. It's very simple. Okay, when the source device doesn't know the destination MAC address, the source device will require the NTP process to find it. NTP process is similar to the ARP process in IPv4. Second, what does a router help to minimize the amount of IPv6 neighbor discovery traffic on the network? Okay, because the router just keeps the neighbor table. It doesn't need to initiate neighbor discovery for every destination host. The next, how does IPv6 minimize the impact of the ND process on network hosts? Is in IPv6, there is no broadcast address. IPv6 use a special multicast destination MAC address to listen to the neighbor discovery message. So only a handful of addresses would be listening to the neighbor discovery messages, which includes a portion of the node address. The last question, how does the neighbor discovery process differ when a destination host is on the same LAN and when it is on the remote LAN? I give you the answer. All right. So when the destination host is on the same LAN network, only the host that matches the IPv6 address responds to the message. Other devices drop the packet. And when the destination host is on a remote network, the MAC address of the local LAN default gateway interface on the router becomes the destination MAC address. Then the router keeps searching for the MAC address of the destination device on the remote network. The router will then place the corresponding IPv6 MAC address pair in the IPv6 neighbor table, similar to the ARP table in IPv4. But there's a little bit difference between IPv4 ARP table and IPv6 neighbor table. It is about their location. In IPv4, the ARP table is stored in both switch and router. We need to use different command to access the ARP table. On the switch, we use command show MAC address table to access ARP table. On the router, we use show ARP to access ARP table. And in IPv6, the neighbor table is only stored on the router. We use command show IPv6 neighbors to access neighbor table. The switch doesn't do anything to layer 2 information. Switch only pass the packets. Okay, we finished this package IPv6 neighbor discovery. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and share with your friends and leave comments. See you next time.